So let's pick it up now. We're moving forward to our 15-minute goal of learning of all of Algebra 1 in 15 minutes. The next topic has to do with polynomials right here. So polynomials involves values that are given to you like a binomial, for example, and then they tell you what is the value of this expression if n is equal to 3. Well, you just say 3 plus 5, which would equal, of course, 8. So here's the thing, though. With polynomials, there's something called the rules of exponents, which you need to understand before you use them with polynomials. So what are some of the rules of exponents? Well, one of the very first and fundamental rules of exponents involves the idea that if I have the same base and I'm multiplying, then I add the powers of the things that I'm multiplying, right? That's one of the rules of exponents. If I have the same base and I'm dividing, then I subtract the powers one from the other. So make sure you review your rules of exponents. That is very important when it comes to algebra concepts. We have that in our book, Tools for Mastering Mathematics, which you can find on my website, livingsensibly.org, or you can email me and I'll send it to you. So that's the rule with polynomials. The next thing is you need to understand that when you're dealing with the rules of exponents, you could have situations where you're multiplying polynomials like this. And in this case, people use the word foiling, where they take the first multiplying, and then the outer, then the inner, and the last. So we'll get a squared plus am plus am plus m squared. So that's a squared plus 2am plus m squared. Okay, so that is called multiplying polynomials. You need to be comfortable with multiplying polynomials and dividing polynomials, and that happens in algebra as well. Very good. The next topic after that is called factoring. Factoring involves situations where you're given a trinomial or just a certain polynomial, and you can remove something that it has in common. So here's an example. If I have 2x squared plus 2x, and someone tells me to factor that, well, 2x is common to both terms, so I can write a 2x outside, and then I have x plus 1 inside. So that is factoring in action. Greatest common factor is what happened there. I apologize, we might go a little over 15 minutes, but we'll be landing our plane shortly with algebra concepts. So this is called taking out the greatest common factor of these two terms. The other type of detail that happens in factoring involves a situation where you have x squared plus 3x plus 2. And we use something called the AC method. The AC method simply means that there's a number, whatever the number in front of x squared, in this case it's 1, you multiply that by this number by itself, which is 2. You multiply those two numbers, you get 2. So you find two numbers that multiply to give you AC and add to give you 3. Those two numbers in this case are basically 2 and 1. So the answer to this problem is x plus 2, x plus 1. You are factoring polynomials when a is equal to 1. That's what this problem is. But there are situations where a is not equal to 1, and you have to factor those polynomials. The difference in that case is that you just have to take a few more steps, but you can still get to your destination and all will be well. Just know that there's a different technique that you would use when a is not equal to 1. In that case, you would also find the AC, what are the two numbers that multiply, and then you would find what two numbers multiply to give AC and add to give B. You take those two numbers and they replace the middle number here, the middle term, and then you factor by grouping. So just remember that factoring by grouping is what you would need to do to finish using factoring methods when a is not equal to 1. Okay, very good. So that's the general gist of factoring. One more key item. There's something called the difference of two squares, which is simply if two things are, there's a difference between them and they're both squares, you can do this. There's also something called the difference of two cubes, and there's something called the addition of two cubes. But there is nothing called the addition of two squares because that's prime. So keep that in mind. There's formulas for each one of these. The second formula here would actually be this, and then the third formula is actually a plus b into a squared minus ab plus b squared. So notice that the trick with these formulas for the difference of two cubes and the addition of two cubes is that they both start with the sign that matches the specific one, but then as you do the difference of two cubes, notice it's positive and positive inside this parentheses on the right. When you do the other one, it's going to be a negative in the first term and then a positive in the second term. So that's how we do the difference of two cubes and the addition of two cubes. Okay, now you take this knowledge and you apply it in rational expressions. So you apply it when it comes to rational expressions such that somebody could ask you x squared plus 6x plus 5 divided by x squared plus 5x plus 4. In this case, you would actually have x plus 5, x plus 1, and then x plus 4, x plus 1. The x plus 1s can cancel, so the answer to this problem is x plus 5 over x plus 4. It is important to note that there is something called excluded values in algebra. So basically, you have to write down what value can you not have in the denominator. And in this case, the answer is negative 4, because if you put negative 4 in here, it will make this undefined. So in math, it's important to know about domain and range. And now I'm getting a little bit into some typical Algebra 2 books, but you guys get the gist. There's a domain and a range for a function to exist. There's worksheets that I have for my students and sort of like a formula document. So make sure that you request one where it shows you the domain and range for all the different types of functions. And these can also be found at the back of typical pre-calculus textbooks. Okay, very good. So rational expressions, we learn how to add, we learn how to subtract rational expressions from one another. So the same principle you use for fraction addition in the pre-algebra is the same principle you need here. You need a common denominator. So you multiply the top and bottom on the left side here by x plus 7 over x plus 7. And you multiply the top and bottom there by x plus 5 over x plus 5. That's how we deal with adding and subtracting rational expressions. Another big topic when it talks about rational expressions is complex fractions. So what happens if I have x plus 2 divided by x plus 5 divided by x plus 7 over x plus 6? Well, this is like a over b divided by c over d. So you simply do this. A over b divided by c over d is equal to a over b times d over c. So that's the general formula for basically working with complex fractions. You can make them into that situation, and now you can put x plus 2 over x plus 5 over here, and then x plus 6 over x plus 7 over there. And that will take you to your destination. Excellent. Algebra students should definitely be comfortable converting from one unit to another. That is a standard practice. They should also be comfortable with solving an equation by cross multiplication. What does that mean? If I have x over 6 is equal to 10 over y, the idea is, depending on what you're solving for, you cross multiply. So then xy is equal to 60. And then if I'm solving for x, I divide both sides by y. So x is 60 over y. So be comfortable with the idea of cross multiplying two terms across from one another. Okay, very good. Another big topic in algebra is called radicals, where you're basically learning how to work with radicals. And so if somebody says the square root of 28, you should know that that's the same thing as 2 times 2 times 7. We can take out the 2 times 2, so that's 2 squared root of 7. That's how we reduce a radical to a simple form. So we should be comfortable adding radicals. So 2 squared root of 7 plus 3 squared root of 7 will be 5 squared root of 7. So basically you treat it like terms. And remember, like terms are situations where you have the same variable in the same power. So nothing here is like terms. But the moment I make an x squared there, these two are like terms. Same variable in the same power. So students learn about radicals. They learn how to multiply and divide radicals in algebra. They also learn how to rationalize the denominator. And then there's an introduction of something called complex numbers, where it's the square root of a negative number. That's where you get into imaginary numbers. Very good. Now we get into a little bit of Algebra 2 as we begin to land our plane for real. And that's where you get into quadratics, and you talk about the quadratic formula and completing the square. Now, some Algebra 1 textbooks will teach you this, but remember in math, we have a lot of stuff we try to cover every year, but people don't master the content. Imagine if we spent time learning those first 8 sections that I talked about: equations, graphing, inequalities, systems of equations, polynomials, factoring, rational expressions, and radicals. That's a good dose to take in. And you can learn that in 3 months, which we have access to that you can use from our website. We can take you through all of Algebra 1 comfortably in 3 months. So then these last 2 topics, we can focus on those as well in Algebra 2. But in Algebra 1, you should be comfortable with the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac over 2a. So that's the quadratic formula. We can derive it using the completing the square approach. And that's part of what we do in algebra, is using the quadratic formula to factor certain types of polynomials. And finally, we're going to end with functions. When we talk about functions, we have to talk about function notation, different types of functions, operations with functions. You can add functions, subtract, multiply, divide. We can find the inverse of functions. We can look at different types of functions, such as logarithmic functions, with trigonometric functions, exponential functions, and inverse trigonometric functions. So you hear things like SOHCAHTOA, but we teach that in geometry as well, so I'm not going to go into detail. We teach that in trigonometry, which is a course on its own. But let me end with one thing. My friend, well, he's not really my friend because he died like a long time ago in 1783, but a man by the name of Leonhard Euler gave us an interesting formula. His birthday, or he was born April 15th of 1707. But basically, Leonhard Euler is the one who gave us this notation of f of x. So if somebody says f of x is equal to x plus 2, first thing to note is that you graph that as a u with the base being at 2. That's how you graph x squared plus 2. But if somebody says what is f of 5, then you substitute 5 in for 2. Leonhard Euler gave us the notation of f of x. He was born in Basel, Switzerland, which is, he was born at a time where we got a lot of progress in math. The Bernoulli brothers were there. His father was his teacher was actually Bernoulli, a gentleman named Bernoulli. And then his classmate was Daniel Bernoulli, who came up with Bernoulli's principle that we talk about when we talk about how do planes fly. And so Euler, I'm going to end this series of algebra by telling you about Euler. Euler wrote a book called The Elements of Algebra. It's a free book. We have access to it. I encourage you to read that book for fun, just because of how beautiful Euler writes his math concepts. Euler spent time explaining concepts well, even though he's the best mathematician the world has seen in terms of abundance of work and quality of work. He was a prolific author. And Leonhard Euler, who was a wonderful man, he loved God, he loved truth, he loved the study of the word, just like, of course, he had that ability in math, but he also loved to study, and his faith was instrumental to just how he lived. He was a wonderful guy. I love Leonhard Euler. But Leonhard Euler wrote a book called Elements of Algebra. Check it out. Please know that algebra is beautiful. It is gettable. I know we did a fast forward run through all of algebra. If you missed the first part of this video, please look at it on our channel. Otherwise, I hope you've enjoyed this quick overview of all of Algebra 1 in less than 25 minutes. Take care and have a blessed day.